In today's lesson, this is section 3.2 in our Trig book, and we're going to talk about radians and degrees. So our concepts for today, we're going to understand what a radian is, we're going to convert from degrees to radians, and convert from radians to degrees, and a little bit more than that even. So this is an explanation of where radians came from. You just need to understand basically that radian is a measurement, just like feet, inches, miles. Degrees and radians are very closely related, and we'll talk about how, but they're a relatively new concept, and they only showed up in the last half of the 19th century. So, if we have a circle, and we have what's called a central angle, meaning it stems from the center of the circle, and it cuts off an arc. Now, if the arc is in equal length of the radius, so whatever length this radius is, this arc is the same, that's called this circle has a measure of 1 radian, and we're going to abbreviate radian, if you'd like to abbreviate it, with rad. Let's move on. So let's talk about our formula for arc length. Theta, which is the central angle, if it's measured in radians, is equal to S over R. And then if you read up here, S is the arc length, and then R is the radius. So basically, if we want to write that in words, the central angle equals the arc length divided by the radius. But the key to this is that the central angle has to be in radians. So if you have it measured in degrees, this formula would not necessarily apply. You'd have to do a little conversion, and we'll talk about how to do that in a minute. So first example, a central angle of theta in a circle has a radius of 3, I'm going to kind of highlight that, and cuts off an arc of length 6. So this is our radius R, this is our arc length S. The radian measure would be S divided by R, or 2 radians. Now if you have a degree measurement and you would like to convert it to radians, the way we're going to do that is we're going to multiply, this is a multiplication symbol, not an X, by pi over 180. And if you think about your chemistry life, when you did dimensional analysis, this makes a lot of sense. First of all, 180 degrees would be measuring from here to here. And if I told you that 1 full revolution was equivalent to 2 pi radians, again, we'll talk about that later, and this is half of that, that would be 1 pi radian. So pi radians is equivalent to 180 degrees, and that's why this works. So what I'd like you to think about, and I'm just going to write it out the long way this first time, if you have 45 degrees, when we do dimensional analysis in science, or stoichiometry, in order to cancel out the degrees, you'd have to put the number of degrees on the bottom. That's why you see 180 degrees in the bottom of this formula. And then pi is on top. Now radians are always really pretty numbers, and generally want to leave them in terms of pi. So when we leave this in terms of pi, we have to reduce the fraction. So what I want you to type on your calculator is 45 over 180, not the pi, just type 45 over 180, and you can reduce the fraction, of course, by hitting math, enter, enter. So that's a 1/4. So this answer is actually pi over 4. And that's how we want to leave our radians. Convert 450 degrees this time. So again, we're going to multiply it by pi over 180. So on your calculator, I need you to type the 450 divided by the 180, and then math, enter, enter that if it's a fraction, which it is. So that ends up being 5 over 2, and then we usually put the pi in the numerator, so it's 5 pi over 2. If you put the pi next to the fraction, that's also correct. And when we want to go the other direction, we'd multiply by 180 over pi, because if you have radians, which has a pi in it, you need to basically cancel the pi out, so we need it in the denominator. And then we want to end up with degrees. So the pi's will cancel, and 180 divided by 6 is 30 degrees. So our next example is 4 pi over 3 radians. If we multiply it by our conversion factor, again, you'll see that the pi's will cancel out, and then on your calculator, I need you to type 4 times 180, and then divide that by 3, and I believe you end up with 240 degrees. Generally, the degree measurements will come to really nice whole numbers. Sometimes fractions or decimals would be better in a degree measurement. Alright, this is your unit circle. So we talked a little bit about the first quadrant in the previous lesson, but this is the whole unit circle expanded out, and you'll notice that I don't have any of the measurements for like cosine and sine, the x and y coordinates. We can figure that out in a second. But you do see the similarities. They've already converted all of the degree measurements to radians. So 30 is pi over 6, 45 is pi over 4, 60 is pi over 3, and so on and so on. Now one thing I want you to notice is, whoops, this is pi over 6, which is 30 degrees. So this is 1 pi over 6. If I travel another set of pi over 6, 2 pi over 6, that would be right here. But remember the fraction 2 pi over 6 reduces to pi over 3. So 2 pi over 6 reduces to pi over 3. If we had 3 pi over 6, that would reduce, where was I at? to pi over 2, which is right here. So you notice we're counting by 30 degrees, and that makes sense. This is 30, 60, 90. So the next time we would end up, that would be 4 pi over 6, which reduces to 2 pi over 3. 5 pi over 6, which is 5 pi over 6, and then 6 pi over 6 is pi. So if you're really good with your fractions, this is not that bad. If you're not so good with your fractions, you're going to have to kind of estimate some of these things. Or not estimate, excuse me, memorize some of these things. So sine of pi over 6. If you remembered 30 degrees, remember the ordered pair, this would be a really easy question. So since you kind of already have the first quadrant memorized, it's square root of 3 over 2, comma 1/2. And remember, the first part of the ordered pair, the x value is your cosine, and the second part is the sine. So the sine of pi over 6 is 1/2. Let's see. The other thing you could do is on your calculator, you could put it into radian mode, because these are radians, and you could literally just type sine pi over 6, and it would come out to 0.5 on your calculator, which obviously you know is a 1/2. Remember these, in the unit circle, these values keep popping up a lot. 0.5 is 1/2, of course. The square root of 3 over 2 is a decimal that you're going to see a lot as well. Square root of 2 over 2 you see a lot. Okay, example 7, 4 times sine of 7 pi over 6. So if you'd like to refer to your unit circle, 7 pi over 6 is over here, which is a relative of the 30-degree angle. So again, he's going to be square root of 3 over 2, comma 1/2, but because of the quadrant he's in, he's actually negative square root of 3 over 2, negative 1/2. So 4 times the sine of that is negative 1/2. So that reduces down to a negative 2. And in example 8 at the bottom, they want us to plug in pi over 6 for the x. So 2 times pi over 6 would actually be pi over 3 plus another pi. So 1/3 pi plus 1 pi is 4 pi over 3. So this is really 4 times sine of 4 pi over 3. If you refer to your unit circle, here he is. And he's a relative of the 60-degree angle. So if I think about what quadrant he's in, he'd be a negative 1/2, negative square root of 3 over 2. And 4 times the sine of that would be 4 times negative square root of 3 over 2. And when you reduce that, you get, let's see, negative 2 square roots of 3. And that concludes our lesson on 3.2.